Welcome to your Pythagorean theorem lesson. Today we're going to review some concepts of Pythagorean theorem, how to know if a triangle is a right triangle, and how to find missing side lengths or hypotenuses of a right triangle. Alright, starting off with the first one. If triangle ABC is a right triangle with legs A and B and hypotenuse C, so here are our legs A and B, and A and B are legs because they're on the shorter side, and the hypotenuse is the longest side, which is opposite of the right triangle. Right, so you do need to know which one is which. A and B's position is interchangeable, but C always has to be the hypotenuse. So if we're given this right triangle, then we know our formula is a squared plus b squared equals c squared. So a squared right here, b squared right here, and then c squared is right here. So if we square up both sides and we add them up, that should give us this total of the hypotenuse squared. Right, so we can use this to find missing legs or hypotenuse. Pythagorean triples. So these are a set of non-zero whole numbers, a, b, and c, so that a squared plus b squared equals c squared. So these are pretty much predetermined sets of Pythagorean theorem numbers that work, that fit into the Pythagorean theorem. So we're going to start off with common multiples and common triples and their multiples. So on the first one, we have 3, 4, and 5. So we're just going to test it out real quick. 3 squared plus 4 squared equals 5 squared. And again, I know 5 goes here because 5 is the longest leg, the hypotenuse, right? Hypotenuse slash longest side. This is 9 plus 16 equals 25. 25 equals 25. Good. So that's the first common triple, but if we do any multiple of it, it should also work. So if I double all the numbers, so 3 times 2 is 6 squared plus 8 squared equals 10 squared. This is 36 plus 64 equals 100. And this will also work. So any multiples of the initial triple will also work. So we have 3, 4, 5. We also have 6, 8, 10. We'll also have 9, 12, and 15. Moving on to the next one, 5, 12, 13. We also have their multiples of 10, 24, 26. We have 15, 36, and 39. We have the next triple is 8, 15, 17. Go ahead and fill out these next two ones. Fill out their next multiples. This one would probably be times 2, times 3, times 2, times 3. Go ahead and fill it out and check your answer with the ones in the front. And we can use this theorem to determine whether a triangle is a right triangle. Any multiple of a triangle will be a right triangle. So we'll keep that in mind moving on.